Particle motion revisited. We first discussed particle motion in the applications of derivatives unit. In that unit, we discovered that taking derivatives allowed us to go from position to velocity and acceleration. However, we never investigated the possibility of going from acceleration to velocity and then to position. Well, now that we know how to integrate, we are able to look deeper into these types of problems. The two most useful ways integration is used with particle motion is using the velocity equation to calculate displacement of an object or the total distance traveled by an object. The displacement is an object's location relative to its starting point, and distance is how far an object has traveled in total. To better understand the difference between these two terms, let's examine the following scenario. You walk 20 meters forward, and then 12 meters backwards, and finally 4 meters forward. The distance that was traveled is 20 plus 12 plus 4, which is 36 meters. However, your displacement is only 12 meters from where you started. In other words, we're taking our final location, or the location of where we ended, and we are subtracting our starting point from it. And we're only calculating how far away from our starting point we are. Now let's look at another example. The graph of an object's velocity is given below, and we will assume horizontal movement of the object. We can see from this graph that the object was moving to the right from time t equals 0 to time is equal to 2 and 446 thousandths seconds. And then it went back to the left from 2 and 446 thousandths until 3 seconds. That's what the positive means, going to the right, and then this negative value means going to the left. Integrating the velocity from time being equal to 0 to time being equal to 3 yields 2 and 94 thousandths. Is this value the displacement or total distance traveled by the object? Take a moment to pause this video and think about it, and when you're done, unpause it. Well, integrating the velocity from time being 0 to time being 3 finds the displacement of the object. In other words, it is 2 and 94 thousandths meters to the right from where it started. This ends up happening because the area under the axis is negative, and thus gets subtracted from the other region. To find the total distance, we would need to add the absolute value of the two regions together, which would be 2 and 228 thousandths plus the absolute value of negative 134 thousandths is positive 134 thousandths. And when we find the sum, it will be equal to 2 and 362 thousandths meters. If the definite integral below represents the displacement of the object, how can we algebraically represent the total distance traveled by the object without knowing when the graph falls below the x-axis? We can actually find this value by taking the absolute value of the velocity function in order to make both areas positive, and therefore would represent the total distance. And the work that we just did leads us to the following conclusions. The displacement of an object is found by integrating from a to b the velocity function with respect to time. And whereas the distance is equal to the integral from a to b of the absolute value of v of t, or the absolute value of velocity with respect to time. Let's try an example with particle motion. A bug travels with a velocity v of t, which is equal to the cosine of pi t, feet per second, for times between 2 and 5.5 seconds, including both endpoints. Part A. how far does the bug travel on the given time interval? And part B, how far is the bug from where he started at the time value of 5.5 seconds? Let's begin with the first question. How far does the bug travel on the given time interval? Well, because it's asking for how far the bug's traveling, that's going to have to do with the total distance. So therefore, we're going to set up our integral from velocity to position, but we're going to include the absolute value in there. So we have the integral from 2 to 5.5 of the absolute value of cosine of pi t, and we're going to integrate with respect to t. So let's actually evaluate this integral on our calculator. So we have math, go to option 9 for integration, and we're going from 2 to 5.5. And now we have to put in our function inside of the absolute value, and that's found in our math options. Go to number, option 1, ABS means absolute value. And we're doing the absolute value of the cosine of pi times our variable. I'm going to use x as the variable, and we're going to integrate with respect to x with the calculator. And when we get that value, it's going to be 2 and about 228 thousandths feet. Now let's look at question B. How far is the bug from where he started when he gets to the time value of 5.5 seconds? The problem here is asking us for the displacement. So we're just going to set up the definite integral from 2 to 5.5 of just cosine of pi t dt. And now that we know what we're integrating, we can evaluate this in our calculator. So we have the integral from 2 to 5.5 of the cosine of pi times the variable, and whatever variable you use in your integrand, you're going to integrate with respect to that variable. And when we evaluate this, we get about negative 318 thousandths of a foot. This means that the bug is 318 thousandths of a foot to the left of its starting position.